In section 3, we're going to take a look at applications of systems of equations, which is word problems. And a lot of situations can actually be modeled and solved using a system of equations. And the benefit to a system versus a single equation is that you can solve for two quantities at once instead of one. In our first example, we have that twice a number minus a second number is -1, and twice the second number added to 3 times the first number is 9. Find the two numbers. The first step in solving any word problem for a system of equations is to define your variables. And the nice thing about word problems is that you get to choose your variables. You aren't restricted to X and Y. You can use different letters if you want. I'm going to use X and Y for this example. So I'm going to let X be my first number and Y equal the second number. Defining your variables is really important because it helps you know what you're looking to solve for and helps you pick out the information from the problem that will give you your two equations. So in this instance, my first sentence is one of my equations. Twice a number minus a second number is -1. So twice my first number, 2x, minus my second number, y, equals -1. My second equation is going to be from the second sentence. Twice the second number added to 3 times the first number is 9. So 3 times the first number plus 2 times the second equals 9. So now I have a system of equations, and I can now solve this system of equations either by substitution or elimination. And I'm going to go ahead and use elimination here because my y's already have opposite signs, and I can go ahead and make them the same by multiplying this first equation by 2. So we end up with 4x minus 2y equals -2, and then 3x plus 2y equals 9. Go ahead and add our equations together. The y's will cancel, and we get 7x equals 7. And then when we divide, we end up with x equals 1. Now I need to plug that into one of my original two equations to solve for y. So I'm going to plug it into the second one. So 3 times 1 plus 2y equals 9. So we get 3 plus 2y equals 9. We will subtract 3. So we end up with 2y equals 6. Divide by 2, and we get y equals 3. So the two numbers are 1 and 3. Another reason why we always define our variables is because you get to choose your variables. If I had just solved this equation, just said x equals 1, y equals 3, how do I know which is the first number and which is the second number? So that's why defining our variables is also important. Now let's go ahead and take a look at some word problems where we are solving for variables that you might see kind of in everyday life. So Jim needs 320 feet of fence to enclose a rectangular lot. The length of the lot is 40 feet more than the width. What are the dimensions of the lot? So basically it's asking what are the length and width of our lot. So this is one of those examples where I'm going to use variables other than x and y. So I'm going to let L be the length and W be the width. Our first equation is going to come from our first sentence. So we have 320 feet and we need to have a rectangular lot. So what this is telling me is the perimeter. So I have 320 feet that I have to enclose in a rectangle. So the perimeter for a rectangle is 2 times the length plus 2 times the width equals our perimeter, which is the 320. Our second equation comes from the second sentence, where it says the length is 40 feet more than the width. So that tells me that my length equals 40 plus the width, because more than is the operation addition. So now I have a system of equations and it is set up perfectly for substitution. So we're going to take the 40 plus w and plug it in for the L in our first equation. So we get 20 times 40 plus w plus 2w equals 320. Now we want to distribute our 2 into our parentheses. So we get 80 plus 2w plus 2w equals 320. Combining like terms, we get 4w plus 80 equals 320. Subtract 80 from both sides. We're going to get 4w equals 240, and then we'll divide both sides by 4, and we're going to get w equals 60 feet. So then for my length, which is 40 plus w, I get a length of 100 feet. So in word problems similar to this, where we're going to have units for our problem, when we get to our final answer, we do want to make sure we include those answers. So I don't want to just leave it as w equals 60 and L equals 100. I need to include my units from the problem. And since the length and the width are both in feet, we put feet. Next, we're going to take a look at a geometry example. So we want to find the measure of two supplementary angles such that the measure of the larger angle is 32 degrees greater than the measure of the smaller angle. So here I'm going to use x and y again. So I'm going to let x be the smaller angle. And I'm going to let y be the larger angle. My first equation is going to come from, in the first sentence, the statement that we are looking at two supplementary angles. So if you don't remember from geometry, that's fine. I don't require it, but two supplementary angles are angles that add to 180. So we have x plus y equals 180. My second equation comes from the fact that my larger angle is 32 degrees greater than the smaller angle. So my larger angle is y. It is 32 more than smaller, which is x. So again, another equation that's set up to use substitution. So we're going to have x plus 32 plus x equals 180. Combine like terms, we get 2x plus 32 equals 180. Then we are going to subtract 32 from both sides. We get that 2x equals 148. Divide both sides by 2, and we get that x equals 74, and then angles are in degrees. So there's our smaller angle. Our larger angle is 32 degrees more than that, so we do 32 plus 74, and y is 106 degrees. All right, let's take a look at some examples involving rate, and this could be rate regarding money, or it can be rate regarding speeds. So our first example says that two trains leave Tulsa, one north and one south. After 4 hours, they are 376 miles apart. If one train is traveling 10 miles faster than the other, what is the speed of both trains? So I'm going to let X be the northbound train. And I'm going to let Y be the southbound train. So in order to get my first equation here, we are going to use the information that after 4 hours, the trains are 376 miles apart. There is a formula from science that tells us that the distance you travel is proportional to the speed at which you're traveling, r, multiplied by the time it takes you. So d equals rt. So we're going to use that to get our first equation. So we know our distance, 376, and we know the rate at which both trains are, we know the time it takes both trains to go is 4 hours. So we'll get 4x plus 4y. Our second equation is going to come from the fact that one train is traveling 10 miles per hour faster than the other. It doesn't specify here which train it is, so we're going to go ahead, we'll just say it's the northbound train. If I give you a problem like this on an assignment or quiz, I will specify which train we're talking about here. So we'll say that x equals 10 plus y. Again, we have an example with substitution. So we'll have 376 equals 4 times 10 plus y plus 4y. Now we're going to distribute the 4 into the parentheses. So we get 376 equals 40 plus 4y plus 4y. Combining like terms, 376 equals 8y plus 40. Subtract 40 from both sides, we get 336 equals 8y. Divide both sides by 8. And we get that y equals 42, and then my units here are going to be miles per hour. So to solve for my other train, the northbound train, we'll just do 10 plus 42. So x is going to be 52 miles per hour. If you ever want to check your solutions to your system of equations for the word problems, you do the exact same thing when we were just solving using substitution or elimination. You can plug in the values you got back into your original system and make sure that both of them end up being true statements. Our second example is going to involve money. So we have a group of neighbors went to a play. There were 10 more adults than children with a total paid admission of $620. If the adults paid $12 and the children paid $8, how many adults and children went to the play? So here I'm going to let A be my number of adults and C be the number of children. So far in all of the examples we've done, a sentence has given us one of our equations. But here we are going to have some of our information for one equation in one sentence and then some for the other in a different one. So for our first equation, we know that there were 10 more adults than children. So that's my equation. So the number of adults is going to be 10 plus C. The second equation comes from the information regarding money. So we know that there was a total admission of $620. We also know adults paid $12 and children paid $8. So that tells me that 12A plus 8C is going to equal 620 because it has to deal with the price. So a lot of the times when we have a system of equations word problem, you're going to see substitution appear more frequently than elimination. So this is again an example where we're going to use substitution. So we have 12 times 10 plus C plus 8C equals 620. Again, distribute into our parentheses. We get 120 plus 12C plus 8c equals 620. Combine like terms, we get 20c plus 120 equals 620. Now we're going to subtract 120 from both sides. We get 20c equals 500. Divide by 20, and c equals 25. And when I'm choosing which equation to plug that into, obviously the first one where a equals 10 plus c, so 10 plus 25, so a equals 35. I want to write that as a short sentence. I would have that there are 25 children and 35 adults. All right, so next problem says that a fourth grade class contributed $17.70 in dimes and quarters to the Red Cross. In all, there were 96 coins. Find the number of dimes and quarters that the children contributed to the Red Cross. So we'll let D equal the number of dimes, and Q will equal our number of quarters. In this case, my first equation comes from the fact that there were $17.70 in dimes and quarters. So remember, a dime is worth 10 cents and a quarter is worth 25. So when I write my equation, it's going to be 0.10D plus 0.25Q equals the 1770. So unlike the previous example where we explicitly knew like the cost, this time if we have money like dimes and quarters, nickels and dimes, pennies could be thrown in there, you have to know how much those coins are worth. The second equation comes from the fact that we had a total of 96 coins. So our number of dimes and quarters, so D plus Q equals 96. Because a problem like this is going to involve decimals, I prefer solving these using elimination. So it doesn't matter which variable you choose to eliminate. I tend to choose the one that's got the smaller number in front just so I can try to avoid negatives. So I'm going to eliminate D first by multiplying the entire equation by negative 0.10. Because we want both of the equations to have the 0.10, but one of them does have to be negative. So our first equation doesn't change. 0.10D plus 0.25Q equals the 1770. Our second equation is negative 0.10D minus 0.10Q equals negative 9.6. We add the equations together. The D's will cancel. Then 0.25Q minus 0.10Q gives us 0.15Q equals, and then 17.7 minus 9.6 equals 8.10. Then we will divide by 0.15. And we get that Q equals 54. And then when I'm trying to decide which equation to plug into, I'm going to choose the one that says D plus 54 equals 96. Subtract 54 from both sides. And we get that D equals 42. So we can say that there were 42 dimes and 54 quarters. Last example has to do with candy store. So we have a candy store that sells chocolate for $7 a pound and peanuts for $3 a pound. The manager decides to make a mix of the two and wants to sell it for $4 a pound. How many pounds of each should we mix to get 20 pounds of the new mixture? So this is going to start off the same way as before. So we'll have C for our pounds of chocolate, and we'll have P for our pounds of peanuts. I'm actually going to start with the second equation. So we know we wanted to get a mix of 20 pounds. So that tells me that C plus P has to equal 20. For my second equation, we know that the chocolate is $7 a pound, peanuts are $3 a pound, and our mix we want to sell for $4 a pound. It's not as straightforward as just 7 C plus 3P equals 4, because we have to take into account the 20 a second time. So we're selling 20 pounds of chocolate for $4 a pound, so we have to do 4 times 20. So our second equation is going to be 7C plus 3P equals 80, because I'm making $80 off of this mixture, because I'm making 20 pounds of it and I'm selling it for $4 a pound. Now I'm going to solve this equation by elimination. I'm going to go ahead and eliminate P by multiplying the first equation by -3. So we get -3C minus 3P equals -60. Our second equation, 7C plus 3P equals 80. Add the equations together. We'll get 4C equals 20. Divide by 4. And we get that C is 5. So when I'm solving for my peanuts, we'll do 5 plus C equals 20. Subtract 5 from both sides, and we get that C is 15. So we're going to have, P. P is 15. So we have 15 pounds of peanuts and 5 pounds of chocolate. Please let me know if you have any questions about solving systems of equations word problems, whether that's identifying what your variables are going to be, and especially if you have questions about how to set up the system. Because once you get the system set up, then it's just substitution or elimination. But you have to make sure that the system of equations that you've written is correct before you solve it.